without heating would be considered poor. Okay, so if you can't afford to warm up your house and you have to stay in the kitchen, then you are poor. So the standard of living of your country does affect the sense in which you are poor. So that's why people use the relative measure. Now, the absolute measure also have drawbacks because, first of all, prices are different, radically different from country to country. So living with $10 a day or $2 a day in the United States, you just don't have enough to eat. Whereas in many countries, in rural parts of many countries, $2 a day and your own little field where you can grow vegetables and fruit, and maybe you have a goat and you can milk the goat and so on. So that's the standard. So even absolute measures of poverty have drawbacks. So people use both, and then they count extreme poverty. So there's a lot of measures. So it is complicated. But coming back to your point, yes, the drawback of any measure of inequality is that it just takes relatively. Okay, so how do we do that? Fine. Okay, so we saw the Pigou-Dalton principle satisfy the Gini coefficient satisfy the Pigou-Dalton principle, which I think is a desirable property. And let's see how it links to inequality. The simple diagram in two households as usual. Suppose we have a social welfare function W that translates the total, all the incomes of all the households in the economy into a single number. Okay, so it's a number between 0 and 1, or between anything really, that gives me the welfare of society. Let's assume that it's convex. Okay, so has got the nice convexity properties, and we also want it to be symmetric. Okay, so we don't care who's got the income. Okay, if I swap two incomes, then my welfare fund. So I don't care the name I don't care about the name of people. Okay. Then we have this this theorem, which I'm going to illustrate in a picture in a second, and it says, suppose that we have two distributions, two countries with two different distributions. Suppose the Lorentz curve don't cross. Okay. Then any social welfare function which is symmetric, so it doesn't care about the name of the people, and concave gives a higher level of welfare to the distribution whose Lorentz curve is closest or closer to the main diagonal. Okay, so if this says in shorter and less precise terms that if your welfare function is concave, then less inequality is better. Okay? Now, what does concavity of the welfare function mean? Suppose you have... Have I lost it? No, okay. Suppose you have... Here you have income of one person, and here you have welfare. So there's only one person. This is very trivial. Okay? Concavity means this. Well, no, it doesn't go down, it goes up. Okay? Yeah. And that says, so if, and then in more dimension is the same, except you think about 3 dimension, and just about do it, so it goes up that way, being like a dome. And so, what does that mean? It means that my welfare increases more for a given increase in income. So this is my increase in income of this person. And when the person is rich, the same increase in income gives me a much smaller increase in welfare. Okay? So this is big, and this is small. Okay? So that's what concavity buys you. the fact that you prefer to give money to the poor. And if that's true in dimensional, then of course inequality. So if you have two people, one has income here and one has income here, then your welfare, and if your utilities, if your social welfare is the sum of their utility, then your welfare increases if you take 1 unit of income from this person and give it to that person. But that's a Pigou-Dalton principle, right? That swapping people, as long as you swap their order, swapping income from people, if you transfer money from the rich to the poor, increases your reward. So, so that's the theorem. And I had an illustration of the theorem, but it is what else have I got here? Okay, so there's a converse that if the Lorentz curve crossed, then I cannot order them, in the sense I can always find income distribution such that the welfare function cannot, what says this is better or this is worse. Which means that Lorentz curve have, without appealing to other requirements, for example, that like weight transfers to the poor more than transferred to the middle class. Without that, I cannot do more than just compare the Lorentz curve, and that will necessarily be incomplete. There is a policy that changes the distribution in such a way that the new Lorentz curve crosses the older Lorentz curve. I cannot say whether that improves or reduces inequality unless I define inequality with some stricter constraints. Okay. And while we might agree on the ranking of inequality according to Lorentz curves, when we start comparing Lorentz curves that cross, then it's not obvious which is better. So we might all agree. You know what? A long time ago. And then I've done it another time, and then I gave up. I suggested that we buy colored chalk. And I don't think they cost a lot more than just white chalk. Did I get a reply? So suppose you have these two Lorentz curves, not just one color, you want many colors. So I want to draw a blue curve, so I can tell you the blue curve exactly. So these two Lorentz curves, so I do dotted. This is dotted and this is solid. We here all agree that the solid curve is a society which is more unequal. Okay, that's demonstrated there. But what if you have this situation? So this is one. Let me do it dashed. This is one Lorentz curve in one society, and this is another. Okay. I got more poor people in the solid society, but at some point less. More, and also more rich people. Okay, so this is a society with a relatively smaller middle class, which is more unequal. Do you have a view? I don't know. I don't. I would say it depends. Okay.